Hi all. So welcome back. I felt like we haven't seen the last video memory allocation in that detail that we should know. So I'm creating this video to know in detail about memory allocation. So we all know when Java program runs, so JVM allocates memory to all the variables, objects, methods, or whatever properties we have, or whatever methods we have, whatever things we have, the JVM is responsible for allocating memory to those. But what memory it will allocate is a question here, right? Either stack memory or heap memory, because we have only these two memory, right? So we'll see what happens and what is this process called. The process of allocating memory that JVM is allocating is known as memory allocation, and in Java we basically have either stack memory or heap memory. So suppose you have a study table, okay, and a large storage room. Think of it as a storeroom you have in your home or any room, and there you have one study table, okay. So study table is small, it's fast, and temporary work. Whereas you have one storage room, okay, that is big, and for long term things you keep. Like, for example, a storeroom in a house and one study room in a house. So study room is we have is quite small because it's for kids and it will be fast, and here will is just for temporary work. But storeroom will be large to store long term things, right? The same is the concept of Java. Think of the small, fast, temporary memory as stack and the long term storage things as heap memory. Okay. So JVM basically is divided into, or Java memory is divided into multiple parts. But for us, the only two things we need to remember is stack memory and heap memory. Other things that we have is method area, PC register, native method stack. That is of no use for us. No one is gonna ask you about all these things. Okay, for beginners, we just be aware of stack and heap. Now, what is stack memory? And don't get confused with DSA topics. In DSA, what we have is stack data structure, right? You can think of it in that way, but for now, think that like you don't know anything about DSA, you are just studying Java, and we are gonna see what is stack memory. Stack memory stores local variables, method calls, references of objects, temporary data, and as same as stack works. Last in, first out. Whatever item you are adding, the last you will add. The last item will get popped out first. Okay. So we have always seen in data structure, we create a stack like this, or you can consider the if you are attending a wedding or in your home also, if you have kept so many plates one after the other, the one plate that you have kept at first will go at the like bottom, and whenever you try to take out the plates, you will take from top. So that is last in, first out, or first in, last out. Okay. This you can call. So this is what we have, or what we call as stack memory. We'll see with diagram how it is storing local variable, method calls, and everything later in this video. For now, the features of stack memory is it is fast, temporarily, automatically managed, thread specific, and stores method execution data. So now, what is heap memory? Heap memory stores objects and instance variables. Whenever you create an object using a new keyword, we have already seen the memory that got allocated is the heap memory. And this is the memory that is larger than stack always. Okay, larger, slower, and this is managed by something we call as GC, that is garbage collector. We'll see what is the garbage collector in this video only. So for now, if someone asks you what is heap memory is the kind of memory that Java have that is used to store objects and instance variables. Heap memory stores data of it stores basically objects. It is a shared memory. It is larger than stack and slower, and it is being managed by garbage collector. Now, what are the examples of memory allocation? For example, first of all, we see that we have a class named student, and in this we have a property, or we have a variable named age. And in main method, we have created a class using a new keyword, and it got allocated with heap memory. Till now, you are clear with this, and we are just assigning the value of age as 25 to the object S1 of a class student. Okay. First of all, main method will get loaded that we have already seen, and it will enter the stack memory. Which memory this method will? We have already seen that stack memory will store all the method calls. So main is a method. So stack memory will store this. For now, let's consider this as stack memory and this as heap memory. So first of all, whenever our Java program starts execution, it will see the main method. So this main method enters the stack memory. Think of it like this. This main method enters the stack memory. And another thing, when it enters the main method, what here it can see the student class and the S1 object created from the class student. So S1 variable will get created, the reference variable S1 will get created, and then the object will get created using the new student, and actual object will get created in this. The object that will get created will be in heap memory, but its reference will be there in stack memory. We'll see with diagram later. See, the reference S1 here is stored in this stack memory, but the actual object, whatever it is created, will be in heap memory. Okay. Now, fourth step will be reference stored. Address and reference of heap memory will be stored in S1 inside the stack. Now, you can consider it like this. This we have a stack, and here we have a heap memory. First of all, the main method it will load. So first of all, main method will come inside stack. Then inside main method, whenever we are creating a student S1, it will get created in stack memory, but actual data it has, whatever object it has, and whatever properties like age we have assigned 25, that will be there in heap memory. Okay. Objects live in heap, reference lives in stack. The S1 is reference. Okay. And this is the most important interview question that will be asked again and again. The difference between stack and heap memory, and where is the reference of object is stored, and where is the actual data of object is stored. So now you can answer. The reference gets stored in the stack memory, and the actual object is being stored in the heap memory. Now another example, we have int x equals to 10. Here x is a local primitive variable, so it will get directly stored into stack memory. Okay. No heap involvement will be there because we are not using any new keyword and we are not creating any object or something. Okay. Primitive variable will always stored in stack, and object is always stored in heap, but the reference will get stored in stack. Primitive variable stores actual value and object stores references. Primitive variables are faster as compared to object. Objects has a larger memory, and that's why it is somewhere slower, sorry, not smaller. Now, example of multiple objects. I think this is the best example to make you the clear of the concept of stack and heap memory. So this is the stack, this is the heap. Okay. So first of all, what you are doing here, you are creating S1. So the reference will get stored in stack memory, but the actual data that you will be assigning, for example, S1 dot age equals to 10 you are doing. So that age equals to 10 will get stored in heap memory. Now you created S2 object, so its reference will be there in stack memory, and the actual data, for example, S2 dot name equals to JK. So this name equals to JK will be there in heap memory. Okay. So S1 object 1 will be there in heap memory. For S2 also object will be there in heap memory. So now each object gets separate heap memory. The heap memory will not be same for these two different objects. Okay. Now what happens during method calls? For example, you call this method. We have already seen when a method, this is consider this as stack and this is heap. We know already that whenever a method we enter, we have it inside stack memory, right? So new stack frame will get created, and whenever the method will get finished, this stack frame will get destroyed and automatically cleanup happens here. Okay. Now, next is we just saw that stack frame is being created, stack frame is being destroyed automatically. So what does this mean by stack frame? So we'll see what is stack frame. Whenever or every method calls creates, it creates its own stack frame, which will contain the data that method is being containing. For example, local variables, method data, and the partial result. All these will be stored in this stack frame only. For example, we have a test class here in which we have created a method one in which we have a primitive variable a which have been assigned a literal 10, and using the main method we are just having a primitive variable with value of x is 5 and we are calling method 1. So whenever we are calling this method, it will call the method that is present in this test class. So first of all, if we have this stack memory and consider this as heap memory. By the way, here is no involvement of heap memory. First of all, whenever a JVM starts a program execution, we always know it enters the main method. So main will get pushed in the stack memory, right? Then what we have is this method one call main, because these are just a variable, they will get stored here. Here it will in stack memory, first int x value of x5 will get stored. Then method one is being called. So this method one adds gets called here in this stack memory. It will be loaded. Then once the program execution ends, this method will get destroyed first, because stack always follows LIFO order or FILO order, we can say last in first out or first in last out order. And then once this method is done, then the main method completes and the frame of main method will get removed. Okay. So here the main concept was to make you understand that last in first out, or we can say it as first in last out. Now you are aware of if take data structure, then it's very easy for you to understand. Now somewhere or whenever you are doing some Java programming, you must have seen the stack overflow error. So if method calls endlessly, then this stack overflow errors come. Stack fills completely. Whatever storage we have in stack, it got filled completely because a method is calling itself endlessly. Then this errors come, stack overflow error. Okay. Now the concept of heap memory and garbage collection we will see. I already told you GC will see garbage collection. So heap memory is being cleaned by this garbage collector and automatically removes the unused objects. For example, here we have a student class and we have an object student S1, and we have assigned this object with reference as null. So garbage collector will think that this is null. Null means of no use. So garbage collector GC will automatically think that this is of no use and I will destroy it, and it will get removed from heap memory. This is saving it is preventing the heap memory to, if unnecessarily there are many null values or null things there in memory and is of no use. So to prevent the memory and make the memory usage better and to optimize that memory, garbage collector destroys it. This is a very good concept that came in Java of garbage collection. And the name itself is suggesting. Now you must be thinking what all things will be collected by this garbage collector. So object becomes eligible when no references point to it. For example, if you assign S1 equals to null, this means no references pointing to it. No references pointing to it means This is eligible for garbage collector. Now, if you have created an object and you are assigning that a null, means S1 is pointing nowhere and no object exists, this implies this is also eligible for garbage collection. Now, difference between stack and heap memory is very simple. Stack memory is storing local variables, it is faster, whereas heap memory stores object, it is slower. Stack memory is of small size, heap memory is of large size. In stack memory, we have auto cleanup, whereas in heap memory, we have garbage collector cleanup. Uh, Garbage collection, we see what all things are eligible to garbage collection. Remember those. Stack memory is thread specific, whereas heap memory is shared. Stack memory follows LIFO order, whereas heap memory is a dynamic memory. Now, example combining everything. You see there is a class called student and there is a variable age. In this main class, we have a main method in which we have created a variable x and assigned the value 10. And we have created a S1 object and we are assigning that a value 25. So what happens is we have a stack memory in which first of all, as we are entering the main method, this main method will get loaded. Once this main method will get loaded, the primitive value will also get loaded in the stack memory x equals to 10. And whenever this object we are creating, the S1 reference will be there in stack memory, but in the heap memory, the actual data, that is student object and age equals to 25 will be there in heap memory, and will be some relation between this S1 and this. They will be aware of each other. Okay. Now, common mistakes that students make is thinking that objects is stored in stack is the wrong or the misconception which you have. Objects are always stored in heap memory. It is only the reference that is stored in stack memory, right? The mistake two, thinking reference variable stores actual data is also wrong. They are just reference only. They are storing address only. Okay. Mistake three is confusing primitive and object memory. That is also wrong. Int x equals to 10 means it is stored directly in stack. Whenever you create a new like object or you are using a new keyword, that is being stored in heap memory. So this was all about this video. I hope you liked this video and I hope the concepts about heap memory and stack memory is now clear. If you have some questions, you can comment down below. I'll answer all those questions. Thank you. Bye bye.